Video 5 is on inverses. So inverses, when finding a derivative, given that the functions are inverses, like the question says f and g are inverses, you're always going to start with the definition of an inverse and then derive it. So in order to do this, we have to use the chain rule. It always comes back. So the chain rule, so let's talk about the definition of an inverse first. So f of g of x is equal to x if f and g are inverses. And that could be written a different way. That could say g of f of x, whichever one you want can go on the outside, as long as they're inverses. Now, in order for me to find the derivative, knowing that f and g are inverses, I can take the derivative of f of g of x equals x. So that f of g of x, that's a chain rule there. So I have the derivative of the outside, f prime, keep the inside the same, g of x, times the derivative of the inside, g prime of x, is equal to the derivative of x is just 1. Now say I wanted to find g prime. Well, this is just connected by multiplication, so I could divide by f prime of g of x on both sides. And my inverse formula will give me g prime of x is equal to 1 over f prime of g of x. Now say I wanted f prime, I would switch the f and the g, so I would have made this a g of f of x is equal to x. Then that would have given me the f prime here, which I would have been able to solve the same way. Okay, so now that we know that formula, now what kinds of questions could they ask? So when they have f and g are inverses in a problem, two things happen. Number one, you can find the derivative of f or g using the definition of inverse and then deriving it, which I just did. Okay, so number one, you can get this formula. Number two, you know the inverse's functional value. So for example, if I tell you that f of 1 is 3, and that would mean if f and g are inverses, that g of 3 is 1. So I'm just switching the x and y because they're inverses. So that's going to be really helpful in solving this formula because they only have to give me one functional value in order for me to find the other one and plug it into my formula. So example 1, the AP loves to ask these with a table, but I didn't want to put a table on here because everyone's running out of room. So let's do example 1, just a regular, simple question. Let f of 4 equals 7 and f prime of 4 equals 5/9. What is g prime of 7 if g is the inverse of f? Okay, so g is the inverse of f. So I'm going to start with my formula, and I'm going to erase this so I have a little bit more room. So I'm going to start with my f of g of x is equal to x formula because I know that they're inverses, right? And I want to find g prime, so I put the g in the middle because I know I'm going to take the derivative of the inside. So chain rule to unbreak this, I have the derivative of the outside, keep the inside the same, times the derivative of the inside is equal to 1. Now let's solve for that g prime of x. So I'm going to divide on both sides by that f prime of g of x. So I know g prime of x is equal to 1 over f prime of g of x. Okay, so now let's start substituting in. So we know g prime of 7 is what I want to find. So that is equal to 1 over f prime of g of 7. Problem is they gave me f of 4 is 7 and f prime of 4 is 5/9. But I know that since f and g are inverses, if f of 4 is equal to 7, then that means g of 7 is equal to 4. So that's going to help me on the inside. So g prime of 7 is now equal to 1 over f prime of, replace that with 4. And they gave me f prime of 4, so that's good. That's 5/9, so this is just going to be 1 over 5/9. And that's a little fraction in the denominator of the big fraction, so that bottom number is going to flip up to the top. So I can say that g prime of 7 is equal to 9/5. Okay, so this is inverses, and then there's also trig inverses. The trig inverses are your NTK. You also need to know your inverse trig rules for sine and tangent. Those are really the only ones they're going to ask you about. Know them forward and backwards for derivatives and integrals. So just a reminder, we did this in a previous video, but the derivative of arc sine or sine inverse is going to be 1 over the square root, because square root starts with s and sine starts with s, of 1 subtract, because s is for subtract and s is for sine, x squared. And then for arctan, to take the derivative of that, it's going to be 1 over 1 plus x squared. And that plus reminds us of the t in tan. Okay, so those are just some fancy ways for you to remember that.